For the next few class periods, we're going to be studying and analyzing piecewise functions. A piecewise function is a function that behaves differently based on input values, which are our x values. You can see a graph of a piecewise function here. The function behaves this way when my x values are -1 or less than -1. It behaves this way when my x values are between -1 and 3, and it behaves this way when my x values are greater than 3. So it's behaving differently based on a set of input values. Today's video we're going to analyze the graph, and then we're going to analyze a piecewise function when it's given in function form. So let's start by analyzing a graph. This is going to be very similar to what we did previously on our previous quiz. It's just the graph looks different. But what we're asked to do is the same. When they say find the value of the function at 3, f of -3, it's saying when x is -3, y is what? So -3 is right here. The graph, the function, is crossing the y-axis. That means y is 0. When I get the value of f of 2, I look for x equals 2. This is x equals 2, and I look up and down. Where is the function? Because the function behaves differently now. The function's down here when x is 2. That's at -3. So f of 2 is equal to -3. The question, as x approaches infinity, f of x approaches what, is the same concept as before. X approaches positive infinity is when it goes right. X approaches negative infinity is the left arrow, and it's asking what is the function doing. As we go further and further to the right, it's going up. To the left, this is pointing down. This is asking as it's going to the right, it's going up. Up is positive infinity. How many zeros can be a little bit trickier. Zeros, if you recall, is when it crosses this x-axis. Open circle is not a solution. Intersection is a solution. Not a solution at an open circle, or not a 0 at an open circle. This only has one 0. Okay, so let's make a note of that. Not a 0 if open circle. If it were a closed circle, on the other hand, it would be a 0 if it's a closed circle on the x-axis. Okay, I'm going to erase everything I've drawn up here so we can analyze the next part of this. You can keep it there if you've written it on your screen. The next part is analyzing our intervals again. And so remember, when I say go from -infinity to -1, that means go from here, my left arrow is -infinity, to here, -1, and I'm focused solely on this. Don't get caught up on the arrow. In this case, is this going up or down? Is it rising or falling? This is positive because it's a positive slope. Forget that. It's going up from left to right. That's increasing. And then from my -1 here to my +3, looking strictly at that section, that's not going up or down. When it doesn't go up and it doesn't go down, that's when we have a constant function. And our last section from 3 to infinity starts here at the open circle, and it moves to the right and goes up. It's positive. That is also increasing. Alright, at the bottom, just a quick review. This is going to come in real handy as we analyze these functions in function form. Go ahead and try to solve these 3 questions. Again, I'll do the first one with you though. F of x equals 5x minus 1, find f of 2. I'm putting 2 in for x. I'm checking 5 times 2 minus 1. That's 10 minus 1. F of 2 is equal to 9. Press pause and identify if x equals -3 is a solution, if x equals -3 is a solution. to help us answer this question, I've drawn the two different graphs down here. First, x is less than -5, open circle and left. Second, x is less than -1, open circle and left. In both cases, I'm asking if x equals -3 is a solution. No here, because -3 is not a part of that shaded area for less than -5, but yes here, because -3 is a part of the shaded solution for x is less than -1. It's going to be really important that we have this skill, being able to check if a value of x is a solution to an inequality, as we look at the next page and analyze piecewise functions in function form. This is really three completely separate equations. Sometimes the most helpful thing to do is what I had done on the previous problem, and that is to draw in a graph of what's happening here. So I'll do this first one with you. I have two key numbers, -7, it appears again, +1, it appears again. In that order, I would want those numbers on my number line. Now, what this is saying is that my function is going to equal -2x plus 4 every time x is less than -7. Open circle and left. I might actually write in here -2x plus 4. This is indicating that any time I have a number that's over here, left of -7, I'm going to input it into that x. Now, what if x is between -7, including -7 because of that or equal to? That's closed circle at -7. And +1, that means I'd keep going to the right until I get to 1, but that's not an or equal to, so it's an open circle. Any number in this area, in this piece of the function, I would plug into x into this equation. And then lastly, anytime I have x is greater than or equal to 1, closed circle and to the right, no matter what it is, 2, 3, 4, 5, 6, 7, 8.3, my y is always 8. That's a constant function. So, when I'm asked to find the value of the function f of -2, I look to see where -2 goes on that number line. -2 would be somewhere in between here. That means I'm using this function. I'm using 2/3 times x minus 1. X happens to be -2. If it's a fraction, no problem. We have calculators. We put this in our calculator, we make my final answer a fraction, we get -7/3. The function's value when x is -2 is -7/3. And we do the same thing for f of -7. This one's a little trickier. F of -7, it's trickier because there's two things there. Remember, it's only a solution at the closed circle. This is when -7 works, not here. So again, I'm using the function 2/3 times x minus 1. X just happens to be -7. We use our calculators. We get -17/3. The function's value at -7 is -17/3. When is it different? Well, function's value when I have x equals 1. I come over here, the closed circle for 1 is here. There is no x in this equation. That just means the function is always 8 whenever my x is 1 or more. So f of 1 is 8. That's so easy, it's tricky. But that only works when x, in this case, is greater than or equal to 1. And then the last one, find the value of f of -10. -10 would be off to the side here. This case, I have to use this function, -2x plus 4. So I have -2 times x plus 4. My x is -10. I get 20 plus 4, or 24. So let's go ahead and try the last one. I'm going to go ahead and pause. I want you guys to pause as well and try to draw what this looks like on a number line. So I want you to draw a number line here. And if you need to use some extra space off to the side, you can go ahead and do that. Where we just draw this number line. And I'll help you get started. I need to have a -5 on there. And there's another one. I need to have a -2 on there. There's another one. I need to have a 4 on there. There's another one. So those are the numbers I need to have on my number line. Now go ahead and see if you can kind of duplicate what we did. Pause it, try it in pencil. When you're done, unpause to check your answers. Hopefully you have something that looks like this. So what I did is I took my x is less than or equal to -5, I graphed it, and then I wrote right above it the function it applies to. These apply together. Okay? And then, because those are both less than symbols, not or equal to, open circle at -5, open circle at -2. And I connect those. And it applies to that function. Close circle at -2, open circle at 4, and it's always 7 based on my rule. Close circle at +4 and to the right, and I apply that function. Now I can look and see all of my x values. -3, well, that would go somewhere here, means I use x plus 5. Because -3 would go to x plus 5. For -2, I go to the closed circle. My answer is always 7. I know that one without doing any work. -8. -8 is going to be off to the left here. -8, I'm using this function. 1/2 x minus 3. And the last one is 5. 5 is off to the right of 4, so that means use this function, -3x. Now it's a matter of plugging in, substituting. So go ahead and pause. Answer those 4 questions, or the 3 that are remaining, and unpause to check your work. So when I plug -3 into x plus 5, I get +2. When x is -2, based on my function rule up here, if it's equal to -2, my y, or my function, is 7. When I plug -8 into 1/2 x minus 3, I get -7. Make sure you double check that in your calculator if you got it wrong. And when I plug 5 into -3x, I get -15. The key here is to always be able to pick out which one of the 2, 3, 4, 5, however many functions we have. And that all depends on whether this value of x is a part of which inequality. And that's the key to being able to analyze functions that are piecewise functions.